For setting up a scenario, we have to specify two things: topology and the traffic. For topology, we have to create nodes and links, and then protocol parameters. For this tutorial, we'll use default parameters for the protocols. So the things that we have to do are only to create nodes and links to connect them. For traffic, there are several built-in traffic patterns in ns2, such as constant bit rate, exponential on-off, Pareto on-off. Here we'll use constant bit rate (CBR) in this tutorial. The most two important parameters for this type of traffic are interrupt time and packet size. Okay, now we are going to show this in the ns script. The article script. At first, we have to initialize and create output files. Here we create a simulated instance, as we do in other OOP language, and then we create a trace file and an animation file. There are two types of raw outputs in ns2: the animation and the trace, which we'll talk on later. Here we created files to record them. After initialization, we move to create a topology. First, we create two nodes. Here we reference the simulator instance created beforehand to create two nodes, node 0 and node 1. Node 0 will be the traffic source and node 1 will be traffic destination. Then we create a link to connect them here, with parameters of data rate, delay, and queue type. Then we create an agent for the source node. Agents are the source or destination of a network layer packet. Here we create a UDP agent here. First we create the agent instance, and then we use the command attach agent to attach the UDP agent to node 0. And then we create a CBR traffic source, specify a CBR instance, specify the parameters, packet size 500 bytes, and then interrupt time of 5 milliseconds. And then we set another parameters random to make the interrupt time stochastic. So the interrupt time between the packets are not constant. And then we also attach the agent to the CBR. After that, we create a now agent on the destination node. The now agent is like a traffic sink. It will receive the packet and destroy it. After that, we connect the two agents from source to destination. Okay, until here we have created topology for the example, which consists of two nodes sending packets from one to the other. Finally, we specify the discrete event simulation. Here we'll use the simulator instance to schedule events at 0.5 seconds to make the CBR traffic source start, and to make it stop at 4.5 seconds. So there will be CBR traffic between 0 second and 4.5 seconds. At 5 seconds, we call finish procedure. Procedure is like a function in C or C++ language. Here we just do some finish work to flush trace, to close the trace file or name trace file, and then we call the NAM program to execute the animation playback. Here the command execc, just like we call a command from a Linux shell. Okay, this is the script to specify the simulation scenario. Until here we have finished phase 1, setup scenario. And then we'll move to phase 2, run the simulation. Here we'll run the simulation from the Linux command line. Okay, at first I would like to show you that ns is a optical script interpreter. ns into another command line interface. Here I will show some optical grammar, optical syntax. Set I1 and set J2. Sorry, set I1. Okay, here I'll put $I at $J. Okay, these are all optical syntax. Here I'll load the script we have just created. Example 1 tickle. Okay, the run is finished, and then the animation goes up, and we'll get the output here, the trace and the animation file